Welcome everyone. In this video I am going to talk about area and volume using double integral. My name is Sandeep, and in this video I am going to explain the concepts through problem solving. So let's start. What is the area of a region R? Area of a region R is given by the double integral of dx dy, where dx dy is the area element, and if we integrate area element over the entire region of R, then what we get is the area of the region R. Similarly, suppose I take a function of two variable z is equal to f of x comma y. So I hope you are already aware that this represents a surface. So if I integrate f of xy dx dy, means if I integrate f of xy and if I integrate over the region which is the projection of this surface in xy plane, right? So this is a surface, z is equal to f of xy is a surface, and we will consider its projection in xy plane. And if we integrate f of xy over the projection of this surface in xy plane, then what do we get? We get the volume of the region which is below the surface f of xy and above the xy plane. So this gives us the volume of the region which is below the surface and above the xy plane. So let's understand both of these concepts through problem solving. So the first problem is related to finding the area bounded by the curve y is equal to x square and y is equal to 4 minus x square. So as you know that in any double integral problem, if we can draw the region, it is very useful for us. So first of all, y is equal to x square is a very standard parabola which we can easily draw. So this is the parabola, that is y is equal to x square. And if I look at this curve, this is also a parabola. So this parabola will also look like this. This is y is equal to 4 minus x square. I will suggest you to pause the video and think that why I have drawn the parabola like this. Just to give you some understanding about this, I am using a different ink. This is not the part of the problem. So actually this is how the parabola y is equal to minus x square looks like. But we have to draw here y is equal to minus x square plus 4. So what I have to do, I have to shift this black parabola above in the direction of positive direction of y-axis 4 places upward. So what I will get is this curve which I already have drawn. I hope it is clear to you. So let me remove this because this is not the part of this question. So we have drawn the curve y is equal to x square and y is equal to 4 minus x square. So one thing that I need to find out that where does these two curve intersect. So to find out this, we will solve both of them together. So y is equal to x square and this gives me y is equal to 4 minus x square. So what we get is 2x square is equal to 4, okay, and this gives me x square is equal to 2. So we get x is equal to plus minus under root 2. So this point is minus under root 2 and this point is under root 2. Now the region that is being bounded is given by OABC. So we have to find the area of the region OABC. So as you already know that what we have to do, we have to integrate dx dy or dy dx. So here I was writing dx dy. This can also be written as integrate dy dx over the region R. And when I will take the limit of y first, I will write dy dx. And when I will take the limit of x first, I will write dx dy. So that does not matter. You have seen in the previous video that by changing the order of integration, the value of the integration does not change. So here I will take a vertical strip, and I hope you understand that how the vertical strips are taken. So suppose I take a vertical strip and then I have to move this vertical strip from point C to point A, means this is how I am going to cover the region. So see, I am moving the vertical strip horizontally and I am moving the vertical strip horizontally, so this will help us to cover the entire region OABC. So I am writing integration of dy dx. And since I have taken the vertical strip, it will give us the limit of y. The vertical strip gives us the limit of y. So can you tell me that where does this vertical strip start? This vertical strip is starting at the parabola y is equal to x square. So the lower limit will be y is equal to x square. And what will be the upper limit? So this vertical strip is going up to the parabola y is equal to 4 minus x square. So I am writing y is equal to 4 minus x square. And then we are moving it horizontally from the point minus under root 2 to plus under root 2. So this expression will give me the area. This expression will give me area of the region OABC, and this is the region which is bounded by the parabola y is equal to x square and y is equal to 4 minus x square. So this implies what is the area. Now let me evaluate this. So to evaluate this, first of all I have to integrate with respect to y. So here we have dy, so that's the integration will be just y, and limits are x square and 4 minus x square and then dx. Now I put the upper limit and lower limit, so minus under root 2, so plus under root 2, y is equal to 4 minus x square, so 4 minus x square dx. So that is equal to minus under root 2 to plus under root 2 and 4 minus 2x square dx. So this will give me what? This will give me 4x minus 2x cube by 3, and limit of integration here is minus under root 2 to plus under root 2. So now let us put the lower limit and upper limit. So 4x, so in place of x I will put the upper limit under root 2, and then minus lower limit, that is minus under root 2, so it will be also plus under root 2, and then we will have minus 2 by 3 and x cube, so root 2 cube, so that will give me 2 root 2, and minus minus plus also will give me 2 root 2. So what we get in the end, 4 into 2 root 2, so that is 8 root 2, and here we get 4 root 2 into 2, so that is 8 root 2 by 3. So if we simplify 8 into 3, that is 24 root 2 minus 8 root 2. So I will get 16 root 2 by 3. Since this is the area, so we can also write it as a square units, right? So in option, if it is written in a square units, you can write it also in a square units, right? Because we have calculated the area. So area of the region bounded by these two curves is given by this expression, whose value is 16 root 2 by 3. So I hope this problem is clear to you. To make more sense, let us quickly solve another problem. So here they are saying that find the area bounded by the curve x is equal to y square and x plus y minus 2 is equal to 0. So quickly I am going to draw the region, and these are the standard curves, so I don't think you should take much time to draw it. This is y axis, this is x axis, and this is the parabola x is equal to y square. So this parabola looks like this. This is the parabola, that is x is equal to y square, and we have this straight line, that is x plus y minus 2 is equal to 0. So if you remember, we can write this straight line as x plus y is equal to 2, or x by 2 plus y by 2 is equal to 1. So this is known as intercept form. It means that it will make an intercept of length 2 on x axis and length 2 on y axis. So if I join these two, sorry, I need to draw a better line. So just give me a moment, let me remove this line. So I have to join these two lines. Okay, good enough. So I have joined these two lines. So this is the origin O, right, and we have the lines and parabola intersecting at this point, and let me call this point A, let me call this point B, let me call this point C. So the area or the region that is being bounded is OABC. Okay, so first thing that we need to calculate is that where does these two curve intersect. So the curve is x plus y minus 2 is equal to 0, and another one is x is equal to y square. So we can solve it in terms of y. So what we can do, we can substitute in place of x y square. So what I will get y square plus y minus 2 is equal to 0, and we can factorize it, y square plus 2y minus y minus 2 is equal to 0. So it is clearly y can be taken common, y plus 2 minus 1 can be taken common, y plus 2 is equal to 0. So if I simplify, I will get y is equal to minus 2 and 1. Means they are intersecting at the point y is equal to minus 2. Means this this point is minus 2 here, and it is going up to 1, so means this point is 1 here. So what do you think? This is a important point that I am asking, that what do you think, taking a vertical strip will be easier for you or taking a horizontal strip will be easier for you? If you have seen the videos earlier, you might have already realized that taking a vertical strip will make the problem slightly complicated, because if you take a vertical strip here, suppose I am drawing a vertical strip, this dotted line, so you can clearly see that it is starting at the parabola and going up to the parabola. But if I take a vertical strip beyond the point C, so suppose I take a vertical strip over here, then it is starting at the parabola but going up to the straight line. So if we take vertical strip, then we have to solve the problem in two parts. But taking a horizontal strip will help, because if you see, if I take the horizontal strip and try to cover the region using horizontal strip, you can see the horizontal strip is always starting at the parabola and going up to the straight line, because we don't have to take two different kind of strips. So what we can do, we can take the horizontal strip and move it vertically from the point minus 2 to point 1 to get the area of this region. So what is the area? So area will be given by, since this time I am taking the horizontal strip, I am writing dx dy, right? And all the horizontal strips that I have taken, they are all starting at the parabola, that is x is equal to y square. So I am writing the limit of x, that is x is equal to y square, and it is going up to the straight line, that is x is equal to, this is the line, x is equal to y minus 2, so it should be written as x is equal to 2 minus y, because we write the limits in terms of y. And then the limit of y will be minus 2 to 1. So we need to evaluate it. So I am writing minus 2 to 1. Integration of dx is x, limit is y square to 2 minus y dy. And then we substitute the limits, so minus 2 to 1 and 2 minus y square and then dy. So moving forward, integration of 2 will give me 2y minus y, so it will give me minus y square by 2 and then minus y cube by 3. Limit of integration is minus 2 to 1. So let us do the simplification now. 2y means 1 plus 2 minus 1 by 2 y square 1 minus 4 and minus 1 by 3 y cube 1 and plus 8. So let us do the simplification. 2 plus 1 3 into 2 6 minus, this is how much, 1 minus 4 is minus 3, so it will become plus 3 by 2, and this is minus 9 by 3, so minus 9 by 3 is equal to 3. So we get 3 plus 3 by 2, 3, this 6 minus 3 is 3 and 3 plus 3 by 2, so 6 plus 3 9 by 2. So this is the area. In case if you want to write it in terms of a square units, you can write a square units. So basically, if you are clear about how to evaluate the double integral, finding the area using the double integral is an easy thing, because we already have integrated complex kind of functions here. So integrating just dx dy is a cakewalk. It's a simple thing for us. Only thing that we need to be careful about, that how to decide the limit so that the entire region is covered. And in these two problems, I hope you might have realized, in the previous problem I could have taken the horizontal strip also, but I think you might have sensed that taking the horizontal strip here will be slightly more complicated, because there will be two kind of horizontal strip that I have to select. So you can see that above this black line and below this black line, the strips will be different, because the strip below the black line is starting at the parabola y is equal to x square going up to this parabola, but above this black line it is starting and ending at the other parabola. So we have to solve the integration in two parts, but taking a vertical strip will just help us calculate easily. And same is true here also. So here vertical strip will make it complicated, so horizontal strip will work. Now this is a very important choice to make, that whether you have to take horizontal strip or vertical strip. This question is even more interesting because the curve that I have considered here is not a standard curve. X square is equal to y cube and x is equal to y. So let us first draw this region, that what is the region that is being bounded by this. So this is x-axis and this is y-axis. We all know that, and we all also know that the line y is equal to x is drawn like this, equally inclined with both the axis, x-axis and y-axis. So this is the line x is equal to y or y is equal to x. And now we have the curve like x square is equal to y cube and x is equal to y. So if you solve it, you can clearly see that if I put this x square in place of x, if I put y, or we can do it also like in place of y if we put x. So suppose I take x square is equal to x cube, solving these two equations. So I will get what? I will get x square minus x cube is equal to 0. So I can take x square common and 1 minus x is equal to 0. So it will intersect at x is equal to 0 and x is equal to 1. So one thing is certain, that this curve will pass, both this curve means x square is equal to y cube will pass through 0 and will pass through the point x is equal to 1. So this is the point x is equal to 1, this is the point x is equal to 0. Only thing that we need to means this is a point on the curve, because if I take x is equal to 1, then 1 square is equal to y cube, so y will also be equal to 1. So 1 point is on the curve, 0 point is on the curve. Now whether the curve will be below this line or above this line, that is the only thing that we need to ascertain. And I would suggest you to pause the video and think about it, that whether, let me first help you to draw, because the curve will be passing through this point and this point. So either it will be like this or it will be like this. Now you have to tell me that whether it is like this one, the above line, or the below line. So I would suggest you to pause the video and think about it. I am going to continue here. So I will just take a very basic approach. I mean something that which has been taught to us in the early childhood. That suppose I take a point, something like suppose I take a point x is equal to 1 by under root 8. So 1 by under root 8 is basically 1 by 2 root 2. Okay. So if I take x square, so x square will become 1 by 8 and it will be equal to y cube. So what will be y? Y will be 1 by 8 to the power 1 by 3. So that will give me nothing but 1 by 2, right? Because 1 by 8 can be written as 1 by 2 cube. So if I am taking x, suppose this is the point 1 by 2, and so 1 by 2 root 2 will be less than 1 by 2. So it will be somewhere over here. But the y value will be 1 by 2, which will be above this point, means this will be the point here, because for x is equal to 1 by 2 root 2, y will also be 1 by 2 root 2 for x is equal to y. So on the line the point will be this, but corresponding to x is equal to 1 by 2 root 2, for this curve the y value will be 1 by 2, which will be above this. So certainly the curve must be above the straight line. So this is how the curve is going to look like, right? For the curve like x square is equal to y cube, if you put like x is equal to minus x, the curve will remain same. So just for the sake of argument, this curve will have a branch in this side also. Sorry, this will be symmetrical, means the way it looks like in the right, the same way it will look like in the left also. So something like this. Okay. So but this is not needed for us because they are intersecting here in this region. So let me call this point O, let me call this point A. So we have to find the area of the region OAO, means this region. Okay. So to find the area, either I can take a horizontal strip or I can take a vertical strip. I prefer taking a vertical strip. So let us take the vertical strip like this and cover the region by taking a vertical strip which will move from point O to point A, means this point. So now let us write the area. So I hope you are clear that area is given by integration of dy dx, and since I have taken the vertical strip, so vertical strip is all the time starting at the line that is y is equal to x. So limit of y is equal to x, and then it is going up to this curve, that is x square is equal to y cube. So if x square is equal to y cube, what is y? Y is equal to x to the power 2 by 3. So x to the power 2 by 3, and the limit of x is from 0 to this point. What I have written, this is like, this is the point 1. I don't know why it is 0. So this is the point 1. So the limit of x will move from 0 to 1. So we have to integrate now. So limit is 0 to 1. Integration of dy is y, and then x to the power 2 by 3 dx. So if I evaluate it, I will get what? 0 to 1 x to the power 2 by 3 minus x, and then dx. So if I solve it further, x to the power 2 by 3 means x to the power 5 by 3 into 3 by 5 integration. Integration of x is x square by 2, and the limit I have to put is 0 to 1. So if I put 1 here, I will get 3 by 5, and if I put x is equal to 1, I will get 1 by 2. If I put 0, it will be 0. So if I solve it, how much I will get? 10. So 6 minus 5, so the answer is 1 by 10. In case if you want to write a square units, you can write a square units. So I think finding the area is not a difficult thing for you. You can easily find the area, because ultimately you have to do the double integral, and only thing here that is mattering is that whether you are able to decide the limits of x and y appropriately or not. So you can solve more problems from your textbook or wherever you are studying, from whatever resources you follow, you can do it. But I am going to now take problems related to finding the volume of a solid which are bounded by different planes or different curves. So let us take problems related to finding the volume now. So we have to calculate the volume of the solid bounded by the plane x is equal to 0, y is equal to 0, and z is equal to 0. I hope you are clear about this, that in 3-dimensional, drawing the picture in 2 dimension is slightly, uh, it requires some kind of visualization or imagination, but I hope you will be able to do that. So let me call this axis as x-axis and this axis as y-axis. I can take this y or this x also, no problem, and this axis as z-axis. So basically, what is the plane x is equal to 0? The plane x is equal to 0 is the yz plane. Can you see this? This plane, the yz plane. And what is the plane y is equal to 0? That is the xz plane. And what is the plane z is equal to 0? That is the xy plane. I hope you can visualize this. And here one thing that I have made a mistake in typing, that I want to take the other plane as x plus y plus z is equal to a. This is not equal to 0, this is equal to a. So the plane that we have taken is x plus y plus z is equal to a. So if the plane is like this, basically you all have studied about the form of the plane. This is known as intercept form. I am writing it over here. So I can write the plane as x by a plus y by a plus z by a is equal to 1. So it means what? That it will make an intercept of length a on x-axis, length a on y-axis, length a on z-axis. So if I join all these 3 points, what will we get? We will get a plane like this. Let me draw this line, and I will get another line which will appear like this. So we have got a plane. Can you visualize? This is your origin, and this is x-axis, this is y-axis, z-axis. So there are 4 sides. Let me call this point O, A, B and C. So the region that is being bounded, or the solid that is being bounded, has 4 surfaces. This is the surface OAB, then there is a surface OBC, then there is a surface OCA, and then there is a surface that is AB and C. So if we have to find the volume under this surface, so basically what we are going to do, we are going to find the volume under the surface ABC and above the xy plane, right? So if you take the projection of this surface, that is what I was talking about, projection of this surface in xy plane, the projection of this surface in xy plane will be like this. If I can just simply draw the projection here so that it looks clear to you, then if I call this axis as x-axis and now this axis as y-axis, so the projection of this surface in xy plane will be a triangular region, and this will be length a, this will be length a, and this line will have now the equation as x plus y is equal to a, and this is the origin. I hope you are also clear that if someone wants to take the projection of ABC in YZ plane, then the triangle OBC will be the projection. Similarly, if I want to take the projection of ABC in XZ plane, then OCA will be the projection, but I am taking the projection in XY plane. So what I have to do to find the volume, as I have told you, you have to integrate Z and dy dx or dx dy, depending upon whether you are taking the to cover the region, whether you are taking y limit first or x limit first. So I am going to integrate z dy dx. So over the region that is OAB region, right? So basically what should I write? Let me write the limits also. So first of all, z I should write in terms of x and y, because when we are integrating z, we write z in terms of x and y. So here z is x plus y plus z is equal to a, so z will be equal to a minus x minus y. And let me write dy dx. And since I am taking the limit of y first, because I have to cover the cross section or what you call projection of the surface in xy plane, so this is how the projection will look like. I have redrawn it so for better understanding. So if I have to cover this, I will take a strip like this, right? So this strip will start at where? It will start at y is equal to 0, means at x-axis, and it will go up to the line y is equal to a minus x. So I am writing y is equal to 0 to y is equal to a minus x, and then I have to move it from 0 to a or O to a. So the x is equal to 0 to x is equal to a. So I just have to evaluate it. So 0 to a, this point for the point O, the x value is 0, so that is 0 to a, and I have to integrate it with respect to y. So if I integrate, I will get ay minus xy minus y square by 2, and then I have to put the limit, that is 0 to a minus x and then dx. Okay, so this will give me what? This will give me 0 to a, and now I will take a into a minus x into a minus x, and minus 1 by 2 into a minus x square and then dx. So if you want to integrate it, there are multiple ways, but one is that we, and yeah, one more thing, that if I put the lower limit, that is y is equal to 0, everything will become 0, so no need to write. So what is this? This is like let me simplify it. 0 to a, the first term will be a square minus ax minus ax and plus x square, and if you look at this term, if you write a minus x whole square, so you will get a square first, so I will get minus 1 by 2 a square, and you will get x square, so I will get minus 1 by 2 x square, and then you get minus 2ab, so you get minus 2ax, and there is a minus here, so that will make it plus, and 1 by 2 and this will cancel, so you will get ax dx. I am writing dx here in the bottom because we have done no space. So here ax and minus ax can be cancelled. So what I will get? I will get 0 to a, and we have a square term here and half a square, so that will give me 1 by 2 a square, and we have taken this term and this term. Now we have minus ax, and one more thing, we have x square here, half x square, so that will give me plus 1 by 2 x square, and we have minus ax term, so I write minus ax dx. I don't want to move to the next page, so I'm going to use this space here in the left and changing the color. So if I continue this integration, so 1 by 2, and we have to integrate with respect to x, so 1 by 2 a square x, and sorry, and then 1 by 2 x square, so I will take 1 by 2, and x square will give me x cube by 3, and minus ax, so that will give me minus ax square by 2, and the limits are nothing but 0 to a. So if I put the limit, what I will get? I will get, if I put x is equal to a, so half a square into a, so I will get half a cube, and plus 1 by 6 a cube, So I write a cube and minus, if you put a here, so a into a square, so a cube by 2, so a cube by 2, and if you put 0, all the terms will become 0. So this a cube by 2 and a cube by 2 will be cancelled. So what I will get is a cube by 6, and that is the volume of this region which is bounded by the plane, that is x is equal to 0, y is equal to 0, and z is equal to 0, and the plane x plus y plus z is equal to a. I hope you have understood this problem. Basically, what is the idea, that you take the surface and write the surface in the form of z as a function of x and y, and then take the projection of that surface in xy plane and see what is the region that is bounded by the projection of that surface in xy plane, and then integrate the surface over the projection in xy plane. So to integrate it, you know how to integrate. You have to decide the limit and then you have to integrate. Okay. So this answer is a cube by 6. I hope there is no doubt up to this. Now let us take this problem here. Find the volume bounded by the cylinder, that is x square plus y square is equal to 4, and the planes, that is y plus z is equal to 4 and z is equal to 0. See, first of all, understanding that how does the region looks like, especially in 3 dimension, requires some amount of visualization, but I am trying to draw the region also, because if I draw the region, possibly it will help you to understand the problem better. So let me draw the region. So suppose I call this axis here, you know, there are 3 different axis system. So let me call this axis as z axis, right, and this axis as y axis, and in this side I am drawing the x axis. Okay. So first of all, how does the cylinder look like? So let me draw the cylinder. So x square plus y square is equal to 4. So we will have you know, actually z axis is known as the axis of the cylinder. So let me draw it. So I am drawing it like this. This is how the cylinder will look like. It will go up to, you know, infinite length, because it is not bounded. Okay, so I hope I am able to draw a good looking cylinder. And then we have z is equal to 0. So clearly z is equal to 0 is the xy plane. You can see this xy plane is z equal to 0, and we have the plane y plus z is equal to 1. So y plus z is sorry, not 1, I think I am tired now. So y plus z is equal to 4. So basically it is what? It is y by 4 plus z by 4 is equal to 1. So means it will make an intercept of length 4 on y axis and length 4 on z axis. So there will be a plane here which will be like, you know, which will pass through these 2 points. Let me take this point as point 4. Okay, because I have drawn it like this. So basically if you this is a plane, I don't know whether you can visualize. So if it will cut the cylinder, the cross section here will look like this. Can you visualize it? Let me draw it slightly better. Slightly better. How should I draw? Something like this. Okay, so the surface, and just for better visibility, give me a minute, I am drawing this plane like this. Okay, so we have actually a surface. Let me draw it with different colors. So we have a surface which is the part of this plane. I hope you can visualize this. If you, I mean, if you cut the salad, or if you take a cucumber and slice it like this, it will look like this. You know, you just slice it in an inclined way. So, and if you take the projection of this surface in xy plane, the projection of this surface in xy plane will be this. Okay, so what is the idea? How do you find the volume? So basically we have to find the volume of what? We have to find the volume of that region which is lying under this surface and above the plane. Means above this plane means above this shaded region, and under this shaded region means under this shaded region, and above this shaded region we have to find the volume. So how can we find the volume? One thing for your understanding, I am drawing the cross section or projection of this surface in xy plane. So this will be nothing but basically a circle. Circle is given by x square plus y square is equal to 4, right? So this is nothing but x square plus y square is equal to 4. One thing, some of you might be thinking that, sir, here you are calling it a cylinder and here you are calling it a circle, because I hope you are smart enough to understand the context. If I am talking about 2 dimension, then x square plus y square is equal to 4 represents a circle. In 3 dimension, it will represent a cylinder. Same thing has happened earlier also. If you see here, I am taking x is equal to 0. So in 2 dimension, you will call it a y-axis, but in 3 dimension, you are calling it a yz plane. So now let us find the volume, and to find the volume, we have to write the integral. So I am integrating z. So what is z here? Because I am taking this surface and we have to find the volume under this surface. What is the equation of this surface? The equation of this surface is y plus z is equal to 4. So I will write z is equal to 4 minus y, and I am taking the projection of that in xy plane. So that is the projection x square plus y square. So to cover this region, I can take a vertical strip. So if I take the vertical strip, the y will vary from minus under root 4 minus x square to plus under root 4 minus x square. And then I have to move it from this point, which is minus 2 and 2, because it is a radius. So this is how I am going to move the strips, so that entire region is covered. So it will be like minus 2 to 2, and then I will take dy and dx. Now we have to integrate. So let us quickly do that. So I have minus 2 to 2, right? And to integrate dy, I will just get y, whose limit is minus under root 4 minus x square to 4 minus x square dx. And if I sorry, I made a mistake. It is not just dy. I am still thinking in terms of the area. So just let me correct it. So basically we have what? We have 4. So 4 will give me 4y, and we have minus y, so that will give me minus y square by 2, and the limit of integration is minus under root 4 minus x square to plus under root 4 minus x square, and then dx. Now this is equal to what? This is minus 2 to 2, and if I put the upper limit, I will get 4. Y means under root 4 minus x square and minus under root 4 minus x square. So into 2 times under root 4 minus x square. And then we have minus half y square. So what I will get? I will get a square of this. It will give me 4 minus x square, and minus 4 minus x square, right? Minus 4 minus x square. So I close this bracket, and then dx. So this will become basically 0. This will cancel. One thing you also understand, that if I am integrating it between minus this to this, y being an odd function, so integration will be 0. But anyway, I have completed that. So now I get 4 into 2, that is 8, and integration from minus 2 to 2 under root 4 minus x square dx. If you remember the concept of definite integration, I hope you will agree that this is an even function, 4 minus x square, because if you take x as minus x, you will get the same thing. So it can be written as 8 into 2, that is 16, and the limit will change from 0 to 2, and that is 4 minus x square can be written as 2 square minus x square dx. So see, there are different concepts that we have used, but in case if you are in doubt, you should look for the concept related to the derivatives, not derivative, related to the integration, that what it is being done. So what I will write? I will write 16, and now there is a formula which we are going to use, that is integration of a square minus x square. So how do you integrate a square minus x square? So the integration of this is given by, let me write the formula first. So for your convenience, I have written the formula over here, that integration of a square minus x square dx is x by 2 a square minus x square plus a square by 2 sine inverse x by a. You have to remember this, otherwise it is difficult to kind of evaluate. So what I will get here, I will get let me change the color so that it looks good. So x by 2, right, and then a square minus x square, so it is 2a square minus x square, that is 4 minus x square, plus a square by 2, so 2a square by 2 means 4 by 2, and sine inverse x by a, so x by 2, and here the limit of integration is 0 to 2. So now I have to put the limit. So if I put 2 here, the upper limit, I will get 4 minus 4, so it will become 0, right? And if I put the upper limit 2 here, I will get sine inverse 2 by 2, that is sine inverse 1, right? So let me write 16. This term will give me 0 and this term will give me 2. 4 by 2 is equal to 2, and sine inverse 1, sine inverse 1, 2 by 2 is 1. And if I put the lower limit, I will get minus, lower limit is 0 into this will be 0, and sine inverse 0 will also be 0, so minus 0 minus 0. So what is sine inverse 1 value? Sine inverse 1 value is pi by 2, because sine pi by 2 is equal to 1. So I get pi by 2 into 2 means I will get pi. So this will give me pi, and we already have 16. So the answer will be 16 pi. In case it is a volume, so you can write it cubic units, right? So the volume of the volume bounded by this cylinder and the plane is nothing but 16 pi. So I hope you have understood the concept. The concept is that you need to be able to write the surface in the form of z is equal to f of xy. This is the point number 1. Point number 2 is that you need to be able to visualize that what will be the projection of that surface in xy plane, or in whichever coordinate plane you want to take, depending upon the nature of the problem. And then you should be able to decide the limit so that the projection that is there of the surface in xy plane is covered entirely. And for that you have to use the concept of double integral, where you take either a vertical strip or a horizontal strip. Okay, so this is all in this video. We discussed 2 problems related to finding the volume, 3 problems related to finding the area. In case if you find that this video is interesting and has made some sense to you, you can like it and share with all your friends. In the coming videos I am going to talk about change of variables and triple integral. So that's all from my side in this video. Thanks for watching and have a great day. And in case if you have not subscribed it, do subscribe the channel. Okay.